we're excited to present VI-Grade's cutting-edge solution for modeling, solving, and enhancing motorcycle products, VI Motorcycle and VI-BikeRealTime. Leading this presentation is Stefano Badii, Project Engineer and Track Manager at VI-Grade. Join us as we explore the advanced technologies and methodologies that propel motorcycle engineering forward, offering unparalleled insights and opportunities for improvement.
So, good morning, everyone. Thank you for coming. Thanks for the very interesting presentation. And the aim of my presentation today is to show you the VI-Grade solution to model VI motorcycle stuff. I think all of you knows the two products that VI-Grade provides. They are VI Motorcycle and VI-BikeRealTime. And this slide looks pretty familiar to all of you due to the need to reduce the development time to model motorcycle and the necessity to reduce or to zero the physical testing and prototypes. It turns out that having a virtual environment to model the motorcycle and test it, it's necessary. And to create a virtual environment, it is fundamental to have at least a vehicle model to model the bike that you want to simulate, or additional in case advanced components or control system. It's important to have a road model detailed as much as you need to create a flat road or a very detailed and realistic road based on a digital twin model. And except for riding simulator, we need to have a rider model, rider algorithm that is able to ride the bike. The two products that VI-Grade provides to model motorcycle are VI Motorcycle and VI-BikeRealTime. VI Motorcycle is a product based on Adams. So for those of you who knows Adams, you know that you have the flexibility to create and increase the complexity of the model as much as you want. So it's a fully multi-body model that allows you to create from a very simple motorcycle with rigid bodies up to a very complex motorcycle with flexible bodies, control system, or whatever you want. So it relies on an implicit solver by default. That is, let me say, probably the strength of the Adams solver. On the other side, we have VI-BikeRealTime, that is anyway a multi-body model. It is based on predefined bike layout. You know that you don't have the possibility to create whatever you want in BikeRealTime, but you have a different flavors of predefined bike model that allows you to replicate the bike in the BikeRealTime environment. It relies on an explicit solver, and the strength of BikeRealTime that is much faster than real-time to simulate, so it can be integrated in hardware-in-the-loop systems or in riding simulators. Let's now start having a panoramic of the VI Motorcycle environment and the kind of analysis that you can run with this software. So, this is the ecosystem of VI Motorcycle. So, first of all, you need to collect data and start to create a model. And you create a model, and with this model, you can start running simulation. Of course, the process is not, as you know, straightforward, and in a single way, you start to have a starting model that you can use to run simulation, and then you increase the complexity of the model, adding, for example, control system, advanced component, like, for example, entering our physical tire. And the concept is to try to have a unique model that you can use to run all the simulation that you want. The concept with VI Motorcycle in general is to have a single model, and with this model you may want to run handling analysis, but not only, also stability analysis or more complex comfort analysis. And in case also, try to run design of experiment simulation or move to the real-time worlds. In this case, using VI-BikeRealTime, you have the possibility, VI Motorcycle provides a plugin that allows to export the model into an equivalent VI-BikeRealTime model and use it in VI-Bike. The models in VI Motorcycle, the vehicle types, by default, we have two wheels vehicle, but there is no limitation. As you know, in Adams, you can create whatever you want, and with VI-Rider, we are able to cope with 2, 3, or 4 wheels tilting vehicles. In terms of complexity, let me say, no limitation, as I said, so you can add all the compliance and flexible bodies that you want. You might have either a simple model composed by all rigid bodies up to very complex model with a lot of flexible bodies or external control system. Of course, it increases the complexity and the time it takes to simulate. To simulate, unless you have external rider, you need to have a rider simulator, and VI-Grade provides an internal algorithm called VI-Rider that is able to ride the bike. So when talking about the rider, we have VI-Rider algorithm that rides the bike, but also a rider model, a rider subsystem that is a mass or more masses, moment inertia, and stiffness in case, because the rider, as you know, is a very important component of the motorcycle, and most of all, it's not fixed with the bike, but it moves with the bike and changes the bike dynamics. So in VI Motorcycle, you have the possibility to rely on a fully parametric rider, whose posture can be adjusted by moving hard points, and its mass and inertia it is automatically tuned, so you have the possibility to replicate the mass and inertia properties of your rider. The rider is fixed by default, but can move according to external laws. And for some kind of simulation, it's important to have not a rider composed by a unique part, but the rider, a real rider, moves. It's not fixed. It has its own internal compliance. So on demand, we have available an anthropometric articulated rider composed by 16 moving parts and with stiffness and inertia values that you can tune in order to replicate your rider behavior. This is a panoramic of VI Motorcycle infrastructure. It's based on Adams, so we have the software is the same, but we have 2 separate environments to create and simulate the model, and then the post-processor to review simulation results. So to create a model, we need to rely on the template builder, in which you can create the model, so define parts, joints, forces that creates the model. So for any template, you need to rely on template builder to create it, or you can start, in general, the standard way is this one, to start from existing models that are provided with the VI Motorcycle shared database. Once the model has been built in template builder, with a standard interface, you have the possibility to assemble the model, so to have a unique assembly, and with the assembly in standard interface, you can run simulation. You can tune parameter and run all the simulation that you want. And now, in the next slides, we will see the simulation analysis that VI Motorcycle allows you to run. Once the simulation has been built, in post-processor, you have the possibility to review the simulation results and plots, or analyze results. Now we'll move with a panoramic of the analysis that can be run in VI Motorcycle. Let's start with suspension analysis that allows to investigate the elastokinematic behavior of the suspension. It's, in this case, a static analysis that, in which you can move the pad up and down and check the resulting suspension curves. Then we have the two-poster test rig. In theory, it should be a video, but it doesn't start. Anyway, the two-poster test rig, in this case, it's a dynamic analysis that allows to investigate the vertical dynamics of the motorcycle, because you can actuate and apply vertical loads in the pads. It allows to investigate the vertical dynamics and see the frequency response analysis in the vertical plane of the motorcycle. Increasing, this is the last test rig, this is a 6-poster test rig that allows to excite completely the dynamic of the suspension, because it relies on 9 actuators per wheel, so you have 6 actuators in the wheel center, 3 rotation and 3 translation actuators, and 3 in the theoretical contact patch, both for front and for rear. Furthermore, you have an additional actuator, composed also in this case by 6 actuators in 3 rotational and 3 translational direction, and you can apply the dynamic loads that you want, either with analytic function or with external experimental file, and it allows to, for example, investigate the stiffness of your suspension in or the compliance. Motorcycle, let's now move on to the full vehicle analysis. Here is a list of all the full vehicle analysis that can be run. Basically, in VI Motorcycle, we have some canned events that are, it's up to VI Motorcycle to generate the event according to few parameters that the user defines. And in all these events, we have VI Rider, which rides the vehicle following the targets. Here is an example of some graphical user interface of the VI Motorcycle events. As you can see here, you put some parameters, and it's up to VI Motorcycle to create the event for VI Rider, and run the simulation. For any simulation that you run, you have the possibility, of course, to review the simulation results. So you have a list of results that are automatically computed because they are created in our test rig. So you can review the main motorcycle parameters. Here you have some examples. Also in this case, no limitation on the request that you can create and review in motorcycle, because you have the possibility to add all the requests that you want if the channel you are looking for is not among the standard requests. Moving to other analysis in VI Motorcycle, it's a pretty good software to run stability tests, so to check the stability of the motorcycle. In this stability test, you can apply external disturbance to the steering by applying a sinus or an impulse and measure the stability of the motorcycle, evaluating some default metrics that VI Motorcycle provides, or you can create your own metrics. The stability is very important, and VI Motorcycle, it's pretty good to do it because you can simulate and create a very strong model taking into account of some parameters like the compliance of flexible bodies that changes a lot the stability of the motorcycle. The same approach can be done in frequency domain by using the weave and wobble analysis. So relying on the linear solver of Adams, you have the possibility to linearize the model and export the eigenvalues and eigenvectors of the motorcycle, and have the possibility to review the motorcycle modes. Here we can see the two main modes of the motorcycle, that is the weave and wobble. Again, a more complex analysis, we have press maneuvers that allows to run slaloms test in this case, we have two different slalom at 7 meters and 14 meters of distance between cones. Here we rely on a genetic algorithm that generates a family of trajectories, and VI-Rider computes, runs all these trajectories, and the aim is to go through the cones at the maximum speed possible without hitting the cones. So there is also a check that stops the simulation if the motorcycle graphics, so the object of the graphic, hits any of the cone. And here is an example of the press maneuver. Durability simulation are other tests that can be run in which you can test special events like hitting an obstacle or jumping or wheelie. You can run basically anything you want and then review the simulation results. For example, to compute or to check the loads in specific motorcycle parts. And this is the most generic event in the motorcycle in which you can run on a racetrack, reproducing a lap time simulation, for example, trying to replicate a GPS acquisition and run exactly the same test that you have acquired in a track. Let's now move to VI-BikeRealTime. VI-BikeRealTime, this is our real-time solution. This is the ecosystem. The concept is the same as in the motorcycle. And here you have, from the motorcycle, you can export the model to VI-BikeRealTime and use it to run simulation. But, as I said, VI-BikeRealTime is a standalone software, so you have the possibility to do everything in VI-BikeRealTime. In VI-BikeRealTime, the model has predefined layout, so we have this standard model that is composed by 11 degrees of freedom, and you have also additional bike layout together with the standard model that allows to cope with bike variants like the direct shock or progressive linkage, or you have the possibility to rely on the conceptual model in which you define splines that define the unsprung movement with respect to the sprung part, and so you have the possibility to model all the suspension linkages that you want. VI-BikeRealTime GUI, as you know, is composed by spreadsheets for any subsystem, so you need to fill up values for all the subsystems like suspension, frame, wheels, brakes, and there is also a spreadsheet panel that allows you to run more or less the same simulation that you can run in the motorcycle. VI-Rider is the same, so also in this case, you can run dynamic simulation with a VDF, or we have a suspension testing that allows to excite the vertical dynamic, or we have the speed gen motor, the max performance simulation, and again, the press maneuver, exactly the same as in the motorcycle, you can run slalom through cones. I said a lot of things in very few time, and talking about rider, talking about roads, you can imagine and you know that VI-BikeRealTime and VI Motorcycle are provided also with additional modules that allows you to create and edit VDF for VI-Rider. So we have VI Event Builder. We have VI Road, that is the software that is used to edit road or create trajectories. VI Animator to review the simulation results and the animation, and transparent for the user, but very important as internal cores, we have VI Tire and VI Rider that copes with tires and road, and the rider drives the motorcycle. 2 minutes in which I want to show you the upcoming 2024.2 release, and these are the main features. We try to stay to apply the same approach both in VI Motorcycle and VI-BikeRealTime. So with the 2024.2 version, you have the possibility to export the motorcycle as an FMU. and that can be used in Linux environment in simulation workbench. The concept is that, without adding here too many details, there is a configuration file in which you can enter among the parameters the input and output that you want to export for the FMU, and then here you can use the FMU in Sim Workbench, and the movie that you see it here comes from VI Drive Sim, and the motorcycle model here is an FMU exported from VI Motorcycle. We've added an electric template in VI Motorcycle that allows you to model an electric motor. So we have the torque map, braking map, costing map, and a battery model with differential equation written inside the template that simulates the charge and discharge of the battery. And the template is provided with a custom dialog box that allows you to set and tune parameter for the electric motor and for the battery. Additional details are that VI Motorcycle 2024.2 will be based on Adams 2023.4.1, so you can have all the latest development of Adams solver and not only, in particular the event browser. You can rely on the event browser, so use fingerprints, and you can save fingerprints, and also have the possibility to create automatic plot for any of the simulation in VI Motorcycle. VI-BikeRealTime, we adopted the same approach. So also in VI-BikeRealTime 2024.2, you will have the possibility to export the model as an FMU. The target is NI Linux real-time. And again, here, like in Motorcycle, you have a dialog box in which you can set the input and output that you want the FMU to exchange with the hardware, or not necessarily the hardware. And the standard of the FMI used is 2.0.3. Exactly as for VI Motorcycle, we have the electric motor also in VI-BikeRealTime. We try to model exactly the same approach, so you can have the same parameters both in Motorcycle and in VI-BikeRealTime. And to conclude, we have adopted a new output file format for the result file that is MDF4 based on the ASM standard. This is a binary format that is much faster both in writing and in reading, and allows you to save and reload results in a faster way, completely transparent for the user, but it is faster and much more robust than the old and again available XML result file. So that's all for me, and I'm open to any question later.
Yes, I would say later.
Okay.
Thank you, Stefano.